Hello friends, this is Eli from Mystic Circuits. Today I'll be showing you how to build the 0 HP envelope slew. I would say that this is probably one of the harder builds to do. I wouldn't suggest doing it first, just because there's a lot of different components to keep track of, different components that need to be put in a specific way. It's a little tighter than some of our other builds. So if you are doing your first DIY project, I'd suggest starting out with one of our other 0 HPs. The two easiest ones are the I attenuator and the OR gate. The O attenuator is also a good one to start with. But you know, if you're feeling comfortable building this, we can go ahead and get started. So we start off taking everything out of our kit. We want to make sure that all of the parts are in there. First thing you'll see are these step-by-step instructions. This is like the Cliff Notes version of the build instructions, right? If you've built a bunch of stuff before, this is everything you'll need in order to build. There's also this QR code, which is possibly how you ended up here. And, you know, it'll also, if you would still like to have some more thorough instructions on how to build everything, we have a longer Word document with lots of pictures and hopefully detailing all of the instructions quite thoroughly. So if you feel like it would be helpful to have some supplemental instructions to help with the build, go ahead and use the QR code to get there. For now, we're going to go ahead and put these instructions to the side. You can see we sort of have three packages. We have the active components, the passive components, and the hardware. So just starting off with the passive components, you should see three 1K resistors. They might be big or small, sort of depending on what's going on there. A 4.7K resistor. Really, we don't need you to check like the values or anything. Just make sure that you have a group of 3 resistors here, a group of 1 resistor here, and then a 10 ultrafarad capacitor down here. Some of you might have a really early version of this kit that had a taller capacitor. Ideally, you want one of these little short guys. It makes it a lot easier to fit on the board. It's, you know, I only sold a couple early on when I was sort of figuring out how to build these kits with those longer caps. So I'll hopefully go ahead and tell you how to fix that. Also, these, you might not see this piece of paper, but instead you might see the paper inside of this silver bag. I seem to package them in one way or another. I'm trying to do it uniformly where the paper is always inside the bag from now on. So what we're going to go ahead and do now is just take off this bag, and you should see on our paper that we should have 2 components in this bag. I'm going to go ahead and open it. Just this tape is stuck on my finger. All right, so I'm opening this bag, and we should see a couple of parts come out any day now. Any day now. Okay. So these 2 diodes are the 1N5817 diodes. We've got 2 of them, so that looks good. This little tiny black chip is the LTV816. That is also good. So you're going to want to have all of those. And now I'm going to put these to the side. We're going to double check on the hardware. So just pour everything out of this bag. All right. So to start off, we're going to want our circuit board. This is obviously the most important part. It should say 0 HP envelope / slew somewhere on there. We have the lid. As you can see, this says the OR gate. On the other side, it says envelope. The 0 HPs all have 2 sides to their lids. Lets us make half as many boards. And here we have a the bottom we have 2 long sides and 2 short sides. The 2 short sides have holes in them. The 2 long sides have the Mystic Circuits logo. Now we should have 4 nuts and 4 bolts, as well as 4 rubber feet. Just make this all nice and organized, and 4 jacks. All right. So it looks like everything's in here. So what I'm going to do for now is take the case hardware, put it to the side. We're going to keep the jacks around because those need to be soldered. And we're going to start this build off with the passive components. Now, again, if you've never soldered before, I don't advise this kit, but if you've decided you're going for it, you know, it's not the hardest kit, but it's just not what I would pick for my first one, right? So if you've decided you're going to go for it, or even if you have soldered for a while and you feel like you have room for improvement, go ahead and check out the video in the description on the basics of soldering. I've been soldering for close to 15, I guess now it's closer to 20 years. But, you know, and I've picked up a thing or two along the way that, you know, even for people who have been soldering for a long time, you might learn something. I've done a lot of soldering in my time. Let me tell you, I've done some soldering. So go ahead and check out the video in the description if you'd like. We're going to go ahead and start out by pulling out this 4.7K resistor, taking off the paper, throwing it away. And now we're going to find the 4.7K resistor footprint, which is right here. All right. You're going to see a couple other resistors on here. We don't want to accidentally put the 4.7K in there. The 4.7K goes right here. The resistors are noted with their value and then a little circle and a line. And that line indicates the 2 points that we are going to connect with this resistor. So we're going to start out with the straight resistor. You hold it by the body so it's vertical. And then you fold it over into a little U-turn kind of shape, right? And this is how we populate a lot of resistors on the 0 HPs. So we're going to go ahead, put it in there into the 4.7K. You should see it. It's the one that's closest to the little square that's going to eventually hold the LTV 816. I can't remember the name right now, but basically you should see your resistor there. What we're going to do is we're going to hold it in place with our finger, right, so that it doesn't move when we flip the board over. And then we're going to sort of shoot these legs in opposite directions. And we're going to do some adjustments before soldering, but ideally we want our legs to not cover up any of the other holes because solder can travel up the leg and prevent and cause unwanted shorts, right? So we do it over there. You can see maybe solder might go along this leg, go into the other hole. We don't want that. So we're going to do it like this. Unwanted shorts. That would be a fun band name. So 1K resistors. This is our next step. We're going to take those off. Take off the paper. Throw it away. And now we're going to do the same thing we did before. Hold the resistor by the body. Flip over the other leg into a little U-turn. And then we're going to find all the points on the board that are marked 1K. You should be able to see that right there. Go ahead and put that in here. I just quickly folded the legs over. Again, we're going to adjust that afterwards. I apologize if parts of this are out of focus. I'm using a DSLR on manual because when I did the autofocus, it would just freak out and start to do focusing whenever it wanted. So this makes it a little bit easier to control. This is where the next 1K goes, and then we have one last one right here. And don't worry, I'll show these all again once we're done populating them. I like to put the 1Ks with the body facing the white circle just because it looks pretty. But this is where you should see all of your resistors populated. The 4.7K again is right there. The 1Ks are right here, here, and here. And now let's flip things over. This doesn't look too bad to solder. I'm going to move this further out and then maybe make this one go like parallel. And then I might do it like this too. It's always safest to make sure that you don't accidentally bridge some points that are not supposed to be connected. Now, we're going to go ahead and start by tinning our iron. I'll zoom out a little bit. It's always good whenever your iron has been left alone for a little while. Move this out of the way. I was right, it's the 816. Whenever your iron's been left alone for a little while, it is a good idea to hit it with some solder. Make sure that the tip is nice and shiny. Solder, when left with the heat on for a minute, will start to develop some chemicals on the exterior. I believe the technical term is oxidization. And that will cause these kind of brown streaks on the back. It's a lot harder to melt your solder with this brown part than with this silver shiny part. So we like to put a little bit of extra solder on our iron to prime the iron. And now I'm going to go ahead and place my iron on the side of each joint that we want to solder. And again, I say this in every video, but zoom in a bit. It helps to keep in mind you don't want to hit your joint with the tip of your iron. You want it to be along the side. Increases surface area. Make sure that the entire joint is being heated up nice and evenly. And again, what I like to do when doing a lot of solder points at once is I solder all of the points that are facing in the same direction. It's good to just kind of visually verify that solder has actually ended up in the places that it's supposed to before you move along. Do your best not to get solder into any of the holes that are still open, in particular this one because it's very close to there. I'm going to go ahead and bend this leg this way so that we can do all three of these at the same time. Even though it's kind of in an awkward position for me, I think I can still do it. All right. So, put my iron to the side. We're going to go ahead and wait just a second or two because some of these legs could still be hot. And then you just take each one in succession, kind of wiggle it around and make sure that the ball of solder that is attached to the circuit board doesn't move when you do this, right? This is where we're checking that the quality of our joints is good and that we don't have any cold joints, because cold joints will cause problems for you down the line. So now we'll take our wire cutters and cut each leg, doing our best to cut the legs as close to the circuit board as we can. You might have to lift up some of the legs further away from the board in order to do that. And the ideal scenario when doing this is to make sure that the force from your cutter is going directly to the sides and that you aren't sort of grabbing the joint and then pulling away from the board with it, which can happen if your wire cutters are too dull, right? I've had that happen before when I couldn't find a pair of snippers for one reason or another, and so I just use a big pair of kind of more like hardware store wire cutters, the ones that are meant to cut like, I don't know, like 10 gauge or whatever. Like this is that those aren't the right kind of snippers. You want these snippers. Trust me, they will save you a ton of time and energy, and they are well worth the probably $10 you're going to spend. I've had those snippers for a long time, and they have not gone dull. So next up, I'm going to wait on this capacitor because there's a note I want to make for people who have the larger capacitor. So we're going to go ahead and do the diodes next. So go ahead and grab your 1N5817s, and they should be these black cylinders with a white stripe. It's hard to see on camera, but the side that has the, let me see if I can focus this. Yeah. All right. So the side with the red tape on it has an admittedly very dull white stripe, right? And that white stripe indicates what's called the cathode of the diode. And you can see it's also indicated by the tape. In all likelihood, your tape will also look like this, but just in case, you want to double check that you're looking at the white stripe coming off of the diode. And what we're going to do with that white stripe is we're going to find all of the diode markings on our board, and we're going to align the white stripe of the diode with the white stripe that's on our circuit board. You can see in the silk screen of the little area that there's this white stripe. The white stripe from our diode is matching up with it. All right. And you want to make sure not to put these parts in backwards, because if you do, your board will not work. So again, I'm just bending these legs over on the back to hold it still for now. Going to go ahead and do this. Oh, it's worth mentioning, I bent these parts differently than the other ones, whereas the other ones, one leg stays straight and the other leg goes all the way in a U-turn. These ones are both bent in 90-degree angles in the same direction in order to fit into the board. It's a more kind of flat instead of vertical way of mounting these sorts of components. It'll end up looking a bit like a staple once you're done with it. And you want to make sure this diode is going in the other direction. The stripe on this diode is going in the other direction from the first one. If either of them don't look right to you, double check that your board looks like this with the, all right, so make sure that your circuit board is in the same orientation as mine, right? Where we're reading the text in the same direction, not like flipped upside down, right? So we're going to just double check this together before you solder anything from here, all right? These are your diodes, and the white stripe on your diode is on the top one facing to the right towards the in jack. Right here, this is where your white stripe should be. Your white stripe on the bottom diode is facing towards the left, towards your out jack. Okay? I want you to be absolutely sure that this is the orientation of your diodes. If you mess up either diode, your device will not function correctly. Okay? So if you need to, go back and rewatch this, double, triple, quadruple check that everything looks correct in this scenario. And once you're absolutely sure, we're going to flip this over and solder again. It looks like this leg could maybe be moved out of the way if I go like over there. Maybe this one could go more like this way. A little bit. I don't know. I mean, that seems fine. One thing that you can do is you can solder a leg and then wait for it to cool down and then redo the heat. Or rather, wait for it to cool down and then bend it and do the other joint. Looks like it could use a little more focus. All right. So we're going to start off here. Your board might wiggle a little bit while you're soldering. Sometimes it helps to kind of like find a stable position and then push down on the board. All right. So now I've done that. I'm going to do this one. Those both look good. I'm going to go ahead and solder this one. And then bend this away. Solder over here. All right. Again, wait for things to cool down a little bit before you wiggle each leg. It looks like all of those are good. We're going to go ahead and take our wire cutters. I like to throw the legs away immediately to reduce clutter on my table. A little piece of extra solder might be sticking around on your board. This is a good opportunity to clear those away. All right, and I'm doing my best to get as close to the board as possible without either cutting into the trace that's there or pulling on the trace unnecessarily. All right, so next up, we're going to put in the LTV816. As you can see, this is a much harder chip to identify pin 1 because it's all black, so you're looking for black on black. But if you see right there, we can see through the reflection in the lighting that there's a little dot up in that upper left-hand corner. That is pin 1. The dots on these packages always indicate pin 1. That's what you want to be looking for. And pin 1 on the circuit board, it's a little confusing, but basically pin 1 is always at the top of your board, and pin 1 at the top of the board is indicated with this curve on the top of the unit. Pin 1 is actually going close to where this 4.7K symbol is. So in order to put it in, you have to pinch these pins a tiny bit. Very hard to do with my left hand, it turns out. And then put it into the board. You can see here, I'll try and orient things for you. All right. So if you're looking in person and you have everything oriented where the name is legible at the top without flipping things upside down, pin 1 is going to the top of your board. All right. So in this case, I'm looking at it like this. Pin 1 is sort of pointing towards the in jack. All right. So we're going to do something we've done a couple times now. What I'm going to do is I'm going to hold my circuit board between my thumb and middle finger. I'm going to use my pointer finger to push down on this chip. And this is so that we can solder just one of the pins in to hold the chip in place while we solder the rest of the pins, because if we just flip it over right now, it might just pop out of the board. So I'm going to start by tinning my iron because we're about to solder as best as I can with one hand. And then I've shown this a couple times before, and I believe I show it in my soldering video. It's been a while since I've watched it. Believe it or not, I don't just watch my old videos for fun, but I like to do this technique that I call the Cobra. It's entirely likely this has an actual name, but this is just sort of what I've learned over my many years of soldering. You make almost like a little paper clip, kind of fish hook kind of shape that's standing straight up and hooking back down like a cobra. And this saves you a hand so that you can hold your chip to the board with one hand. You can hold your iron in the other, and we're just going to pick any corner that seems easiest for you, and you just push it into the solder until it looks like it has made a nice connection there. That connection could look better, but I can clean it up afterwards. It's at least good enough to, let me see if I can focus on that. All right, so you can see here, this pin has been soldered well enough that I can shake the board around. The chip has not moved at all. And we're going to go ahead and just solder all of the pins from there as we normally would, knowing now that our chip is not about to fly away as soon as we apply some pressure to one of the pins underneath. All right. And then once the other pins are soldered, we can fix up the soldering on that pin, because it honestly, it doesn't look good enough to me. So I'm going to go ahead and solder the opposite pin. I'm going to solder the two open pins. Okay, you can see here we have caused what's called a solder bridge, which is where you have solder between two pins that you don't want to be accidentally connected. All you got to do is put your iron in the middle and then kind of swoosh the solder away like an eraser almost. All right. Now I'm just going to reflow this first pin that we soldered and put a little bit more solder onto it so that everything can heat up one more time and make a nice even joint. That looks much better to me. And just for consistency, I like to cut these pins as short as they can. They can make an accidental bridge sometimes. These pins are pretty shallow. I'm going to cut them from this direction, honestly. And I'm doing a sort of more advanced technique where I'm going over more than one of them at once. That was just a reflex. Basically, just trying to get rid of any excess solder. All right, so everything's looking good so far. That's what the bottom looks like. This is what the top looks like. Again, that reflective dot should be pointing towards your in jack. If that is not currently the case for you, good luck. Okay. Now we are going to get to the capacitor. And just to illustrate a point, I am going to grab a larger capacitor. Give me just a moment. Here we have the ideal capacitor. This is what we want to be using. It's nice and short, and so it can fit in the case, right? This is really the biggest reason that I didn't end up using these larger capacitors in order to fit in our case. And something else to note about these capacitors is that they do have a direction, just like our diodes, right? It won't break your circuit if you solder it backwards, but it will eventually break the capacitor, and it will cause your circuit to function bizarrely, all right? So if you look here, you can see this negative stripe on the capacitor. For whatever reason, engineers many, many years ago decided that these capacitors should be marked with their positive leg on the board and the negative leg on the capacitor. So basically the long leg goes to the plus on the board, which goes to the left, right? And now I'm bringing this up because if you were just to solder this in, your case would not fit in because the capacitor is too tall. All right. So if you either have a really ancient kit from us or you bought your own parts and your capacitor is taller than these resistors, then what I suggest you do is you fold it over like that. All right. And if you go in this direction, it will, I don't think you should do it like all the way parallel to the board, but rather like at this little bit of an angle. I guess that actually is flatter. Your mileage may vary. In fact, if you're at all unsure, you might leave this until you're able to put the case together and then solder it. But basically, my suggestion is if you have your own cap or a tall cap that seems like it's going to stick way further up than the rest of the parts, go ahead and just make sure that it's bent in this direction, covering up the bottom 1N5817 diode. If you bought the kit from me in the last, however many years it's been since I've made this video, if you bought the kit from me more recently than 2024, then I would say this capacitor is going to be in your kit. It's short. You don't need to do any of this stuff. And the long leg, once again, goes into the plus on your circuit board. Go ahead and stick it in. And just like the other parts, we're going to hold it in place with our finger. We're going to make the legs go in opposite directions. I do my best to, I shot this one up because there's nothing over there. This one takes a while to get to anything. I'm going to tin my iron really quick. And we solder like there's no tomorrow. All right. Bend up the legs. Everything's looking good. I'm going to cut the legs off. And now we're basically up to the jacks. Home stretch. Okay, so I have a jack here. It has 3 pins on it. You can see for each of these squares where the jack goes, there's 3 holes. So orient the pins with the holes. The side of the jack that is supposed to face the outside of the board should be the part of the jack that takes a plug is the one facing the outside of the board. Sometimes sentences are hard, and you want to just kind of gently press everything in to make sure that these jacks are as flat against the side of the board as possible. All right, everything's looking good. Make sure that none of the jacks are kind of like lifted off the board like this. You see how you can see underneath it? You want it to be pressed nice and firm into the board. You can even give it a little press. And now I just tinned my iron. You might have to raise the heat on your iron just a tiny bit for these lugs. They take more time and heat. You can see here, I just filled in this entire pad with solder. You can't see the hole anymore. That's about the right amount. You don't have to overdo it. Just once the hole has disappeared, you know that you have done it right. Okay, so I've said this a couple times, but those are the only 8 pins you need to solder. If you're at all unsure about soldering these other pins, you might as well just go ahead and do it. They're not actually connected to anything, but it doesn't hurt to solder them in just to be on the safe side. But just know you don't technically have to. Ooh. All right. And again, as a safety precaution, I like to cut these 6 lugs towards the center of the board to avoid any unwanted connections due to the design of the case being conductive. For silly reasons. Is that extra solder? Yeah. This is a good time to look for little beads of solder that might kind of snuck in there. But these are the 6 lugs that I normally cut when assembling these kinds of things. And as you can see, it keeps the profile of the actual solder quite low on this part of the board. All right. So now this is what the top of your board should look like. This is what the bottom of your board should look like. Now we can move on to assembling the case. So as I mentioned, make sure the lid of your case matches the labels for the jacks. On the board it says release, on the case it says time. They mean the same thing. Out should go to out, in should go to in. That's really the most important thing, right? So now we have our lid here for reference, and we're going to start by putting the 2 short sides onto their respective jacks. As you can see, there's a little tab up here. That tab will end up in this slot and this slot, right? And We don't want these holes going towards the bottom of the sides. We want it towards the top. Now, if I kind of align things so that the holes will end up in the right place. Whoop, bent resistor. I'm going to just go ahead and bend it back. Rather, that the tabs will end up in their right place for their respective holes in the lids. You should be able to kind of, you know, it might take some finagling, but yeah, man. All right. Aren't you glad that you're doing this work instead of me? So, I know I am. All right. So, a little bit of wiggling things around, but eventually the short sides have ended up with their tabs put into the lid. If something doesn't seem like it's working right, you might consider flipping one of these sides over. Make sure again that the jacks are sticking through on the side where the holes are closest to the top of the board. If you do it upside down, then things will not fit. Now I have one of the long sides. I like to do it with my name of my company facing up. Okay. Now it's upside down. We're going to take the bottom. And you want the holes on the bottom to sort of align with the tabs that are sticking out. I usually do one side, and then, oh, this one was nice and easy, actually. You can sort of push the other sides with these fingers until they glide effortlessly into the little openings in the bottom piece. All right, so now we have our case assembled, and we're going to go ahead and do the case hardware. So take one of these bolts, put it through the top. It should go through to the other side. If you have any difficulty getting it all the way through, sometimes it helps to take a screwdriver and just kind of screw it through the last couple centimeters. But what I just did there was I put a rubber foot in, and then I put a nut into the cavity in the rubber foot. And now what I'm going to do is I'm going to put my finger over that nut to hold it in place while I flip the case over and use my handy Phillips head screwdriver to tighten that screw. And you might have to apply some pressure. Okay. Oh, I thought that was going to be a good example. You might have to apply some pressure either straight down or to the side to the foot in order to make sure that it is mating with the threading. The bolt's threading is mating with the threading of the nut. But ideally, you're going to have just such an easy time putting these bolts and rubber feet on. Okay, so here's an example. These holes aren't like perfectly aligned, right? So my screw won't go through. I'm just going to gently screw drive it the rest of the way, leaving, not torquing it all the way down, but just making sure that the bolt is going through. Put the rubber foot on, put the nut on, tightening everything. And once the last bolt is tightened, there you go. You have yourself an envelope. I think that this is one of my favorite of the 0HPs, but, it takes a little bit more thought and effort than some of the easier ones like the attenuator and stuff like that. I'm going to go ahead and add a little addendum so that you can test and make sure that your envelope is working correctly. Other than that, I hope your build was easy. Thank you for watching. Okay, I'm going to go ahead and show you how to patch up a 0HP envelope. The first thing that you're going to want is something that's maybe a constant sound source or something like that. I decided to use the Entity Ultra Kick. I'm just sending in a static trigger because it lets me kind of listen to it all in time, right? And then I have a really slow gate coming out of here. here, we're getting a nice long, I might even turn off the internal envelope, make it like really short. You can kind of hear when this trigger is high, we get the pitch going up, and once it decays, we get a descending trigger, or a descending pitch rather. But it's slewing down, right? It's not just turning off. I'll show you. It's good to test the mult output as well. This is what it would sound like without the shaping from the envelope. You can hear it's just happening. It's turning off right away. Now, I'll go ahead and do it like that. And it's turning off again. Now I'm going to take an LFO from the 3-body. You can hear it changing the shape, influencing the timing of the envelope, kind of wiggling things around a little bit even while the envelope is high. But yeah, that all sounds pretty good to me. So hopefully your envelope is working fine, and it was a fun and informative build for you, and it makes you lots of nice patches, and you're having a great day, and everyone you know is doing really well. I hope you're really happy and feeling fulfilled, and that, you know, just lots of great things are happening for you. So thanks for spending the time with me building these kits. This is the last of my testing videos, so I'm very excited to turn off all of these very hot filming lights and finish up. So yeah, thanks again.